Okay, so we're gonna be graphing functions in Houdini tonight, or today, or this day, or whichever day it is. And the original thing was done by Thiago Costa. He's a guy from Brazil. He has awesome work. You should check him out. I got some stuff of his website or his blog, and some stuff he done did with dice before. And we're gonna redo the same thing only in Houdini, and we're gonna skin this cat in four different styles, being that Houdini is so diverse. So let's go ahead and skin this cat, see what we can twerk. Yeah. Okay, so to begin the whole thing, I'm gonna go ahead and dive inside over here. I got the grid set up, and I got a null that holds all the comments pretty much, or it has a comment that has all the functions that were used to actually achieve um, this right here. So we're gonna be graphing well, not every single one of them, but I'm probably showcase two of each at least of the four different styles. So that way, the rest of the potion you can just go ahead and try it out, see what you can get out of it. So you're gonna begin the first one, which is x multiplied by z, and I said we're gonna do it in four different ways. So the first way that I'm gonna go ahead and do it is actually by using a chop manager or chop network, which I'm gonna call chop functions. And I'm gonna go ahead and split this whole thing up into four different categories, kind of sorter. So I'll put the chop right here, so we're gonna know that we are dealing with chops on this side. So chops. Okay, so right here we're gonna begin with our chops, and we're gonna dive inside the chop by double clicking on it, and we're gonna go ahead and get the grid right here. So I'm gonna go ahead and say geometry, get the geometry, and the geometry that we want to get in our case, it's called, well, just you can just call the functions or the grid, whichever one, same thing. And well, you might want to add a motions tab over here just in case you don't have one open. So motion view, and if you actually visualize this, this is our grid as it is. And I'm gonna go ahead and probably increase to get a better resolution of the whole thing. I'm gonna probably go ahead and increase this, probably make it 75 by 75, and as you can tell, everything over here is just flowing down, and it's actually the point positions that you're looking at straight from the top level. So the first function was x. If I might go ahead and edit the comment, x multiplied by z. Now, oops, I'm gonna go ahead and do that in chops. So I'm gonna go ahead and double click on this, and we're gonna have to kind of split up the channels, being that it brings in tx, ty, tz all in one, whatever. You need to split it up, so we can do the math functions separately. So we're gonna use a delete chop, and we're gonna delete everything else which is not tx. So we're gonna delete the non-scope channels. So right now we only have tx over here, and we're gonna name this got tx. Then I'm gonna go ahead and just copy this and paste this, and I'm gonna name this got tz. And what I'm actually going to name over here is the z. So over here we got a z, over here we got a x value. So what we need is the multiplication of both of these. So we're gonna need a math. This is the most used chop in chops, and what we're gonna be doing is hook that up over here and hook that up over here. Now we're gonna be doing the chop over here, the math chop over here, actually multiply the x and the y and the z together. So what you're gonna get eventually is something like this. And being that this is what you actually get, all you need to do, or you actually get an output which is usually called tx. So by middle mouse clicking on the chop over here, you can actually tell what channel is that getting outputted by the chop over here, math chop. So we actually need to go ahead and rename this to ty, because we're actually gonna remerge the whole thing. So this one you're actually gonna go ahead and rename. It's only one channel over here in our case, so to TY. So just type in TY over there, and now pretty much when you think about it, you got an X value, Y value, and a Z value to make the vector back up to make the whole grid one more time. But if you actually realize it, if you actually look at the original grid, if you look at TY, you can actually see that TY is the yellow line over here. So actually, if I go ahead and delete um, delete TY, delete the non-scope channels, you can see TY is just a flat line. So actually TY is the orange line, my bad. So there we go, TY is just a flat whatever. So we're going to replace it with this, the light blue versus the dark blue. So all we need now is actually a merge, and the merge has to be done exactly in order. So X goes first, Y goes second, and the Z goes last. So we're gonna just plug that in right here. This is this, which is the rename, is actually rename Y now. So, and the Z is gonna be the last one. So pretty much when we look at this now, you can see what we're going to be graphing eventually. So some things didn't change. For example, the X and the Z didn't change. I mean, X and Z didn't change, but the Y actually changed a whole lot. So that's our first function, and we're gonna go ahead and export that, and we're gonna call it export. So we're gonna probably capitalize this and export function 1, let's call it. Okay, then we're gonna make sure the blue flag, the brown flag over here is actually selected, so that way you can actually get the whole stuff exported, and you can actually see it's TX, TY, TZ. So the arrangement over here on the merge is really crucial. So once you get that done, pretty much all you need to do over here is actually drop in a channel, and going back to whatever here, you got a flat grid. And all I need to do now is actually just plug in our export function, and now we have our grid manipulated exactly like which guy, this guy right here. Now the only thing is there's a little multiplier to it. So in our case we'd have a constant, probably just something to make it work, and the constant over here we probably have to do a lot of tweaking. So I'm gonna drop in a math over here, and it's gonna multiply the everything over here. Then I'm gonna replug this. Instead of the original math, the multiply going directly, I'm gonna just go ahead and use this, which actually multiplies. So if you actually look at that, this one's actually going to take this position over here. So now this one actually will control or multiply the value of this. So if I go back up to chops and the constant, I gotta make sure that I multiply this. So combine chops, make it multiply, and pretty much now you got the same this right here that he has. So pretty much that's the first function. So pretty much the chop over there, the constant, multiplies all the effect depending on how drastic you want it. And let's go ahead and get to the second function, because things are taking quite a bit of time. So second function will be edit comment, and the second function will be that. So it's x to the power of 2 plus z to the power of 2. So let's see what they can do that in chops. Then we're gonna stop the chops and dive into the second portion. So diving over here, we already got our, I'm gonna go ahead and delete this guy. We already got the x and the z set up. So all we need to do now is actually just, just drop in some math, whatever's math chops nodes, math chop nodes, and it's asking for the power of x and the power of z, and then you both add them both. So in our case, you as there's no power over here, when you think of it, power is just multiplying the same value over again. In our case, the x just gonna multiply it 2 times Now you're gonna get the power of x like that. Then you're gonna drop in another math. Then you're gonna do the same thing for the z. And once you drop those in, now all you need to do is actually just add them up. So you're gonna need another math, which in our case will actually add both of the whatevers, and you gotta make sure that this actually set to multiply. I forgot to do that. So that's the two functions over here that get the two inputs on them. So you gotta make sure they are multiplying. The third one over here, which you actually dropped, is the add. So pretty much you got 2 and 2, then you add both of them. So now this one is the add. So that's the one we're gonna actually rename to ty. And pretty much you're gonna be redoing the same process for every single one of them. And pretty much all you gotta do now is merge all of this. So merge this. Nope, you gotta merge the original x, my bad, with the new y and with the original z. Oops, merge that. So there we go. So you're gonna be having a lot of confusion in seconds. And export will be our last node. Making sure that the brown flag is selected. So shift click, so that way it's actually selected exportable. So export function 2, and we're gonna go ahead and visualize that. So that's graph 1. Then I'm gonna go ahead and drop in another channel over here and plug it in, and I'm gonna name it the same thing as the other one. So it's graph 2. Then all you need to do now with this one is actually select export function 2 and accept, and same thing. Now you got this, which is this guy right here. So what you actually need to do is the same thing all over again. So this one over here, you're gonna have to drop in a math one more time with this one, plug this one to this one, and make sure you plug this back into the constant over here to get a thing to multiply, and also make sure that you put this to multiply the ones just added. So pretty much now the value is a little bit less drastic. And if you actually look, that's this guy right here. So pretty much chops, I really won't mess with it no more. That should be enough for chops. I really won't have to mess with everything. You can kind of pretty much play with it as far as for chops. So we're gonna go ahead and set up with the second style, which will be point positions. Yeah. Okay, so basically all I just did was add a point expression null over here. It has nothing on it, it's just a null. And as far as for the functions, we're actually gonna go ahead and skip them 3 right there, because that's the same thing we just did right now not too long ago. So actually, if I actually go back to chops, and all you gotta do is actually just change this from an add to a subtract, and you get that shape. Change from subtract to multiply, you get that shape, and you still have the constant over here. So you can multiply it or just increase it so slightly, and you get that shape. Or you can actually go ahead and change it to division. See what you get. You get another shape, and you get your constant still. So bigger number, you get, I don't know, probably looks like the other one, but you get the idea. So I'm just gonna go ahead and deal with point expressions. So I'm gonna go ahead and drop in a points up. So I got a points up, and this is the most powerful SOP, I believe they say, or something. Anyway, so typically we're just dealing in the x and z remain the same as far as for the grid positions. X and z remain the same, and y is the only thing that we're actually affecting. So we're gonna be using the expression right here on the ty slot, and in our case the expression should be right there, a comment, and the expression should be let's go for number 7. So cos the cosine of x plus the cosine of z multiplied to the power of 2, or to the power of 2 in our case. So I'm gonna go ahead and leave this over here, and let's go ahead and edit this. So being that we're using H script off the top, we're just gonna type in cosine and the cosine of x. So in our case, that would be $tx, right? And that's an addition of the cosine of $tz, which is to the power of 2. So we're gonna go ahead and just type in POW right here, and it's gonna, the exponent is 2 in our case. Then you can close that. Now he actually did something because the grid actually moved up, you know, from the respective place, but I don't think the thing is too powerful enough to actually be shown over here. So I actually need to amplify the effect in our case. So under the point expression over here, I'm gonna just drop in, I'm gonna edit the parameter interface. I'm gonna go ahead and add in a float, and I'm gonna call it mult for the name, and you can name it anything. I'm gonna just name it something like that, and pretty much I'm gonna go ahead and copy this. Nah, I don't have to. Well, I might have to, I guess, somehow. But what I'm gonna go ahead and do is actually do an attribute create, and the attribute I'm gonna call it x. Then the value over here is gonna be tx multiplied by this value right here. So I'm gonna copy this parameter. Then I'm gonna go ahead and paste copy relative references. So I'm gonna go ahead and type in tx one more time, multiply by that, and I'm gonna do it one more time for the z function. So I'm gonna go ahead and copy parameter, and I'm gonna go ahead and paste copy the expressions and change this to a z. So pretty much all I need to do now is actually name this to z. So I got one expression, which is an attribute create one, which has the x on it, and it has a tx multiplied by the little function we just created over here, and the second one is a z multiplied by the same thing all over again. So now we're gonna go ahead and change this expression over here to now we actually got a function over here which has x and z, which can actually use the $sign with. So in our case, we're just going to use the $sign right there and $sign right there. Now, as you can see, it doesn't do anything different, but actually if you actually go ahead and amplify this, you can actually see now you have that little bumpy thing, of which, you know, you get that ridge kind of sorter, and pretty much you have to play with the numbers a little bit. So over here, you know, you would probably play with the 2, I would say. Well, I guess that's not a good idea, but well, probably not. So you might want to come and play with the numbers a little bit. So probably, let's say over here you might want to multiply by 0.25. Let's see what that happens. You know, you get the more grooves in it. Let's see what happens to the z if you multiply by a number. Guess the grooves become longer. There we go. So pretty much you have to play with the shapes a little bit, and you know, well, being that this multiplier does all the little things, we have, as you can see, that's this particular shape right here. If you don't want the height to be that high, you'd actually have to multiply the whole thing by a particular value over here. So I'm gonna leave that as an assignment for you guys to actually do that, but that's one shape. Let's get to the next shape, which would be this cosine. So I'm gonna go ahead and plug this into a 0.2, and grid goes black to flat. And now that we got our z and x values over here, we're just gonna use those. So we're gonna be using cosine. So cosine of in our case would be, we're gonna actually enclose this well, you have to enclose it. Actually, you can use a power of x to the power of 2, right? And it's gonna be added to the power of z to the power of 2, and pretty much that closes that. And now you need to close the cosine, so double check everything's straight, enter. And well, we created a lot of mess, but that's because of our multiplier over here. Let's go ahead and reduce that, and we get this. Oh, cool. There you go. So we get this big baby over here, which looks like a speak or something, which should be this guy right here. No, that's not the guy. That's this guy right here. He ain't got the little bump inside. This one has. This one, yeah. So that's that guy. So pretty much you can imagine how the expression is gonna be like. So it's gonna be the same thing all over, just repetition. So if you actually do the next one, since they're so sweet, it's the same thing actually. All we gotta do is just change the sign. So I'm gonna just copy this, paste it, and change this to sign. And now you get the little hole thing that we were just looking at. So actually, how this one has the little hole, just like this one, that one. So, and there we go. So we got a little hole, and pretty much that should be it for as far as for point expressions with creating the functions. So you typically do the same thing. Now for the next one, let's when I do this one, let's do that one. Let's do this one over here. The point expressions real quick. Let's see how that's gonna work out. So we're gonna go ahead and plug that in right here, visualize it, and it says -1. So in our case it's gonna be -1 divided by, we have the power of that over that. So we actually can just copy this, copy that, come over here, paste that, and close this and enter. And pretty much that's the effect that you got. In our case, it's just a hole. So actually, if you don't do -1, you can just do positive. So that's the only reason why they did a negative. It kind of does the effect like that. And I'm guessing, let's see what would happen if you actually, I guess it doesn't like that. So we're gonna multiply this by a number. Let's see what happens if I multiply, increase this. I guess Houdini doesn't like that. So, I done, oh, that's to the power of 2. I'm sorry. And I guess in this one, you can actually go ahead and close it and multiply it by that. So now you get a wider range. So I guess you'd have to use the same numbers for both sides. I'm guessing the smaller the number, the wider the base. So I'm guessing on this side will be the same thing. So multiply by 0.15. And pretty much you get a wider base. And being that it's too long, you might want to clamp it. Now let me see if I can remember how to do this. Clamp, float value, minimum value, maximum value. Okay, so what you want to do is actually clamp all of this. That's the float. And so the minimum will be 0, I would say, and the maximum will be 2, probably. Enter. And you get this particular boy right here. So pretty much you can scale this up or down, whichever one you want. And pretty much that's it for point expressions. Let's skip on to the next one, please. We got verbs coming up next, so let's go ahead and kick that. Alright. Okay, now we can actually soup this whole thing up a little bit. Let's go back looking at our functions over here, and we're actually gonna use particles in our case this particular time, so that we can actually just do a little bit different stuff. And we're gonna be okay. Whatever we do in this, you actually do in verbs. It's the same thing, but I'm actually use particles in this one. So I'm gonna go ahead and drop in a pop network on this one, and drop in a source pop, and I'm gonna use the fast context geometry and point ordered, and I'm actually set to be birthed on the very first frame. So use a $FF is equals to 1 for the expression, and pretty much you just you can hard code the whole thing. In our case, you got that many points, or you can actually just script the whole thing to $NPT, and it'll actually query the number of points on the grid and use those. So now we can actually use the var pop to do this. Now essentially this is the same thing as just also initially it's gonna have a a slot just for where it was all just verbs, and we do the whole thing with the verbs up, and same idea. So basically actually you're gonna leave that right there. So we're gonna go deal with this on the pop level in our case, and the expression we're gonna be using in our case will be this one, number 11. So we're gonna dive into the var pop, double click on it, and as usual verbs needs a lot of space. So first things first,